So welcome back to lecture number 12 in the R series. This is the second of the advanced lectures, and today we discuss again ggplot2, and the type of plot we're discussing today is the box plot, right? So this is a typical representation of a box plot data for performance of students in various subjects in a class. So typically any box plot would have a box in the center, and then it will have extensions of the box. These are known as whiskers. And you will have some values will be outside the whisker. These are your outliers. So let's see in details what a box plot is and how a distribution of data can be plotted in a box plot. So box plot represents the data in 5 number summary. These 5 numbers include the minimum number, the maximum number, and these are not essentially the minimum and maximum number of the series. The first, second, and third quartiles. The median or Q2 is basically the 50th percentile or the middle value in the data set. Then you have what is known as the first quartile. This is Q1 or 25th percentile. It is also known as the lower quartile, and it is the median of the lower half of the data set. Likewise, you have the third quartile, which is also known as the 75th percentile. And this is basically the upper quartile, and it is the median of the upper half of the data set. Right? This is your typical box plot. You have the median value here. The limits of the box are defined by the lower quartile and the upper quartile, or the Q1 and Q3. And then beyond Q3 and below Q1, you have the extension of the box in the form of a whisker. The limits of the whisker are defined by a factor of what is known as the interquartile range, which we'll discuss in the next slide. So the interquartile range is the distance between the upper and lower quartiles. Minimum or Q0 or 0th percentile is the lowest data point in the data set excluding any outliers, and this is basically calculated by Q1 or the first quartile minus 1.5 times the interquartile range. So this represents a Q0 or 0th percentile. Likewise, the maximum or the 100th percentile, or what is known as the Q4, is represented by the highest data point in the data set excluding any outliers, and this can be calculated by Q3 or the third quartile plus 1.5 times the interquartile range. So this is basically a distribution. This is Q0, this is Q4, and any value outside Q0 and Q4 is basically an outlier. So with that background, let us move to R Studio and start plotting our graph. So here we are in R Studio. And I'm sure you remember this is a scripting area where you can write your scripts and also load your pre-written scripts, as I've done here. Then in my case, I have my console on the right because I've changed the settings. This third quadrant here represents your environment variable area, and the fourth quadrant is where you will be able to see your plots, right? So this is the area that we're going to use very frequently today. So first, we specify the libraries that you need for your program. So I will be reading 2 libraries. One is read Excel to read the Excel file, and the second is ggplot2 to plot my graph. In case you're using these libraries for the first time, you need to install the libraries here. For installing the libraries, you need to go to packages, and in packages, you need to go to install. When you click on install, a dialog box will open, and this is basically connected directly to the CRAN repository or comprehensive archive network, and here you can write the name of the package that you want to install. So for example, here let's say ggplot2. So you'll have a table, drop-down table, which will suggest what you want to install. So you can select from the drop-down table the package that you want to install and then say install. Also, installation has to be done only once, and any other time, once you have installed, any other time you need the library, you can directly load the library into your script using the command library and in round brackets the library name. So this is how I do it, library, and in round brackets I write read Excel because I needed to read the Excel file, and then the second library that I need here is ggplot2 to plot my graphs. So let me run this part first. And it also gives you an additional message that you could get help from our community at the given URL, right? So next we are going to read the input file and transfer the contents of the input file into an object name called marks, right? So here we are going to read the Excel file now. So for reading the Excel file, we use the function read Excel or the read Excel library. And then in round brackets and arguments, we give the file path. So my file is in F directory, r Vipin underscore final folder, within subfolder advanced, and the file name is bt underscore marks dot xlsx, right? So you also need to give the extension of the file. And then of course, it is equated to marks, right? So the command is marks is equal to read Excel, the file path in double inverted commas followed by the file name here, right? Next, I want to check the file properties. So I can view the entire data by saying in view, and in view the V is capital, and in the arguments I give the object name into which I've read the file, which is marks. So you can run this, and this will help you load the file in the next tab. So here you are, this is our file. There are two columns in the file. One is the subject name and the other is the marks obtained by various students in that subject, right? And you can see in the environment variable area also it says 1480 observations of two variables. So this is typically the long form of the data. There are only two columns. One column is basically for the subject and the other is for the marks obtained by various students in this subject. So if you want to just see a part of your file, you can define head and you can say marks. So this will give you the initial first 6 lines of your data. You could also see whether a file has been read until the end of the file by looking at the tail of the file. So you say tail, and then again you say marks in round brackets. And when you run this, you'll have the last 6 lines of your data shown to you. Then we move on and we talk of plotting the graph now. And remember, we are making a box plot today. So as we have done in the bar graph, first we'll plot the skeleton of the graph and then finally plot the actual graph, right? So we are plotting the skeleton now. In this skeleton, we'll define what is our x-axis, what is our y-axis. We'll also give the axis labels and the title of the plot. We say graph 1 is equal to ggplot, and in round brackets, we say marks, which is the actual object in which the data is contained, followed by a comma, and then we define the aesthetics, that is to define what is the x-axis and what is the y-axis. So in aesthetics, we say x equals to subject and y equals to marks. So this is the first part, but we also want to add the labels. So we say plus, and then we say labs or labels, and then in round brackets again we give the arguments or labels. So the x-axis is to be labeled as subject name, the y-axis is to be labeled as marks distribution, and the title of the plot is going to be class performance report. To check whether everything is going fine, we print graph 1 here. Let me readjust the settings so that we can see the graph in slightly enlarged view. So here we are, this is our skeleton of the graph. You can see the title on the top, class performance report. You could see the x-axis labeled as subject name, and then we have the individual subject names coming up here. However, these subject names are, because they are in the horizontal format, they are basically smudging into each other and overlapping with each other. So we will try and adjust this so that the subject name comes in at 90 degrees to the x-axis. Likewise, on the y-axis, we have the distribution, and the y-axis is labeled as marks distribution. Now, in the next step, we'll first add the actual plot. So this is a graph 2 is equal to graph 1 plus. So this basically essentially means that graph 2 will have all the properties inherited from graph 1. In addition to what was there in graph 1, you also want to add the actual plot. So the actual plot that we're using is Boxplot. So we say geom underscore Boxplot. We also define the width of the Boxplot as 0.4, and then we print this graph here, right? So let me run this part to show you how the graph will finally appear. So here you are, and here is your plot, and you can see distinctly this is a box plot. Each box has a median, lower quartile and upper quartile. This is Q1, this is Q3. And it also has a whisker. So if you see here, this is the lower whisker, this is the upper whisker. These are values that fall within the Q1 minus 1.5 times the interquartile range. Likewise, these are values that fall within the Q3 plus 1.5 times the interquartile range. And then you have these dots, these represent your outliers. However, if you see, our subject name is still overlapping with each other wherever the subject name is long. So now we change the text angle and rest everything is the same as in graph 2. So we say graph 3 equals to graph 2. So which means all properties of graph 2 will be inherited into graph 3. In addition to that, we say plus and we say theme and in round brackets axis.text.x equals to element underscore text and in round brackets again angle is equal to 90, and then we make sure that all round brackets have been closed, right? So this will basically ensure that the names of the subject are now at an angle of 90 degree and are vertical. And then again we print graph 3 to see whether this is done or not. So let me run this part now and you say run, and here you are. You can see now the names of the subjects have become vertical and are clearly legible now, right? So next we would want to make this plot a bit more colorful and more appealing. So we add colors to these box plots based on the subject name. So we say graph 4 equals to graph 3. So all properties of graph 3 that are currently present will be inherited. And then we use plus to indicate that additional action has to be done. And then we define additional features in the aesthetics. We say AES. And in round brackets, we say fill equals to subject. So the color filling will be done based on the subject name. Here is your final graph. This is your class performance report in 12 subjects, and the marks distribution across each subject is shown to you. So typically this is a box plot, and in the box plot, you'll have a box that will be indicative of your first quartile and the third quartile, and the median will be marked with a bold line in towards the center of the box. Not necessarily in the center, depends on the marks distribution again. And then you'll have whiskers, which will be extensions of the box. And then you'll have some values that are called as outliers that are not within the defined boundaries of your whisker ends. So each subject is now color coded and the index is given at the right hand side here. In case you want to change the color pattern, there is a whole lot of patterns that you can select from. The command that we use is scale_fill_brewer, and we can define the palette that you want to use. In this case, we're using the palette names paired. So what we do is we say graph 5 is equal to graph 3. So all properties of graph 3 will be inherited here. Plus, we also define that the color filling has to be done as per the subject. And then in addition, we say scale_fill_brewer, and in round brackets, we give the arguments palette equals to paired. And then we say graph 5. So let me run this part and see how our graph changes. So this is now our new graph where the color pattern is based on the paired palette scheme. And in case you want to download the graphs, you can go to export here, and in export you have 3 options. You can save it as an image, save it as PDF, or you could copy the graph to a clipboard and paste it wherever you want to paste, right? So let's say you save it as PDF. So you say save as PDF. This will ask you the size of the PDF that you want. So this could be your device size, or you could say A4, right? Let's say this one. And then of course it will ask for the orientation. So this is going to be landscape, and you say, and you could browse into which directory you want to save this. So let me just save it on my desktop here, right? So let me say desktop and say open and say save. So this is going to get saved as our plot. So let me also change the name. All right, so let me just save this here. All right, so let me check if it is there in my desktop or not. This one. So here you are. This is the distribution of marks of performance of students in 12 different subjects of a class. So that brings us to the end of Boxplot, and next time we discuss a new plot, which is known as the Violin Plot, which is an even more fruitful representation of the variation that exists in the data, right? Thank you very much.